All right, we're back. In the last video, we kind of worked through this PDG graph up until the retarget, which is basically a fetch that processes this SOP network. And we were going over how to create the appropriate attributes to drive all of that. So now I'm going to kind of talk about what follows and go over that. So here we have this geometry import node, and it's basically looking at the upstream uh, work items. And what this does is it's basically grabbing the last frame detail attribute from the geometry that's processed. So if we come here and take a look at this, we have this attribute here called last frame. And the reason why we want that is because each of the animation clips that we're going to be processing is a different length, and we want to know how long they are so that when we do our renders, we know how many frames we want to render. So that's kind of important. So let's just talk for a minute about how this last frame attribute gets created. So I'm going to come back here to this network. So it's being created here in this wrangle, but the data that we're using is coming from the motion capture import. So when we import our motion capture information, it makes this attribute called clip info. And basically, it gives you an array with some information about it. So the rate, the range in terms of when it begins and when it ends in terms of seconds, right? So it's 22.9 seconds long. And then with the rate, and of course, if we multiply the number of seconds by the rate, we're going to get the total number of frames. So this clip info attribute, trickles through our chain, and we basically have access to it down here. And that's exactly what I'm doing. I'm going and I'm grabbing this detail attribute and rate and range, and I'm grabbing the second index of the range attribute, which you'll remember is 22 seconds when it ends, multiplying it by the rate, right, which is 24, and that gives us our last frame. And so now that I have that information, I can access it with this geometry import. So it's a way of lifting attributes off of geometry, which is very handy for something like this. So the next operator I have here is my OpenGL render. And basically, it's for each item here, it's going to render some frames. And I'm using that last frame to specify how many frames it should render. Each of these work items represents an individual clip or motion capture clip, and I want to make render a series of frames for each of those clips. This is basically what this operation is doing. Some things that I should kind of mention here and that you should be aware of. Before you run the whole graph for the first time, I would highly recommend that you turn off the bypass filter, or the bypass flag on this node here, filter by range. And what this basically does is instead of having 2,500 work items, you just filter it down to 12 work items. And you can test to make sure everything works well for those 12 before going to and doing the whole database, because it takes quite a bit of resources. And you can see specifically why down here. So if you take all of the clips and then render them, you're going to end up with 800,000 frames. And that's a lot of data. So it's something to kind of be aware of. In this case, the OpenGL renderer is a ROP fetch that's pointing to a ROP. that's located right here. And that's basically just outputting JPEGs, so they don't take very much room. And of course, it's an OpenGL render, so it renders relatively quickly. Um, that being said, there are a few things that you should be aware of when executing this. The first one that I'll mention in terms of my setup is I batched these renders into batches of 1,000. Because OpenGL renders so quickly, I don't want to render each frame as a separate process. If I can batch them together, I don't have the startup cost for each frame. So collectively, it'll render quicker and it's more efficient. Some things that you should be aware of. I put this rig together on my laptop and I've been running it on my laptop. But if you have a render farm, using this is, a perfect example of using PDG, and it would be great to leverage your render farm to make use of this, so render it in parallel and process this information faster. However, in terms of rendering and using the OpenGL renderer, one of the things you should be aware of is if you're rendering it on the farm, the OpenGL render needs a graphics card, and your machines on the farm may not have a graphics card. So that's a consideration. The other thing is, even if you have like a machine with a graphics card on the farm, X server, it needs to have a graphical user interface that's running. So if you're using Linux, it needs to have like X server running, or else the OpenGL ROP won't work. So that's something to be aware of. That being said, there are ways to kind of work around that. So you could send all of this to the farm, or you could have your default scheduler set to say something like deadline, right? And so you could have, all of these tops looking at deadline in your render farm if you're using deadline. But when it comes to the OpenGL render, you could, specify that it use the local scheduler node specifically. So everything upstream, would be processed on the farm, but in terms of the actual rendering of frames, you might decide to do that locally. That's an option as well. And then, of course, if you find it's feasible, you could, of course, use a third-party renderer to render these frames on the farm. You'd probably want to dial the resolution and the quality settings to as low as possible because, at 800,000 frames, even if they render very, very quickly, it's still going to take a long time. So that's kind of that on the OpenGL render. Then I take the output from that and I partition based off an attribute. So in this case, it's clip name, which is going to be unique for each of these work items, if you remember. So if we come back here and take a look, clip name, it's going to be unique for each animation sequence. And I basically partition those guys. And so you can see here we had 500 or 2,514 work items. And once I've partitioned these, I now have 2,514 work items. So there's a correlation there. And basically what I'm doing is all the frames that have been rendered for a particular animation clip, I'm just associating them together into a single work item. And then I can feed that into this FFmpeg encode video node, which will basically make a video for each of the animation clips that you can evaluate. So if we, come up to my directory here, and we come to data. Oh, sorry. We come to a folder here. I have an output folder which contains the BGOs that represent all the retargeted animation. And then I have a folder of videos. And each of these files represents a video that we can use to preview the animation that we've made. So yeah, and you'll end up with a bunch of a different movie for each animation clip, and you can kind of preview those and kind of get an assessment of how well your retargeting went. So, in this example, we're doing the retargeting for the CMU database, but of course, if you have an existing library of mocap animation at your studio that maybe you've used for another project and you want to repurpose, this is, a great workflow for that. The last thing in terms of the PDG setup is I have this little set of operators here. And basically what these are doing is they're removing data that was written to disk. It will, if you come and take a look at what gets, wrong folder. Hold on a sec, let me just go find the appropriate folder. Yeah, so if you look at what gets output, you have the data folder, which is basically where the zip archive gets downloaded to, and then it gets expanded into this folder. So that's kind of like the raw data. And then you have the output folder, which represents, the kind of final animation clips and or retargeted animation clips and the videos created from them. But then I also have a directory called temp that basically contains my JPEGs, my rendered images, which, you may or may not want to keep around. So this is just basically a way of, blowing away that kind of source data as well as those kind of temporary files that have been created, if you want to do that. Yeah, so that kind of concludes the construction of the top network. In the next videos, I'm going to talk about some operations for smoothing clips, which can be helpful when processing mocap data, as well as how to, once you've retargeted the clip, how can you take that and use it in your crowd sims. So I'll be talking about that in the following videos.